I'd like to introduce you to Mimi Coutier. She's a high school math teacher at the Park School of Baltimore. This is the question. You told me that sometimes computers, including AI, create errors because they use the binary system. Can you explain?
All right. So first I'll say that I think it's more of a communication error due to the fact that computers use binary, the binary system, but we humans use the decimal system, like the digits 1 through 9, right? We count to 9 and then it's 10. It's like an odometer, right? It cycles around. Um, I'll explain a little more about binary, even though I'm sure a lot of people in the audience know what it is, but it's counting only with the digits 0 and 1, right? So if you look at what I have on the screen here, right? So 0 is 0, 1 is 1. But then you run out of digits after that, so you have to go to 1 0, and that means 2, right? That's the next number. So that's how computers store all of their information. Um, and then we have to go back to kind of middle school math and think about fractions and decimals. So in our decimal system that we all are familiar with, we've got fractions like 1/5, that they also have a decimal representation, zero point 0.2. But also think of a fraction like 1/3, right? So if you go back to your middle school days, it's 1/3 of a pi, something like that. Um, 1/3 doesn't have a nice decimal representation like zero point 0.2. It has a repeating decimal representation, so 0.3333333, right? And I could go on forever, right? But it does. The decimal representation of 1/3 goes on forever. Um, so when humans use the decimal representation of 1/3, they have to round at some point. They can't keep the number going forever. Um, and so that's all well and good. But then when we think about computers, right? So in the binary system, there are also nice decimals that stop and more annoying decimals that go on forever. And what the confusing thing is that those, I mean, whether a fraction repeats or not, it's different in decimal versus binary. So in the decimal system, the one familiar to us, 1/5 equals zero point 0.2. But in the binary system, 1/5, you can read it on the screen, goes on forever. That's an infinitely repeating decimal. So the trouble comes in when a programmer forgets. They're thinking 1/5. They're like, oh, cool, zero point 0.2. I'll just type that in the program, right? But then the computer, when it sees zero point 0.2 and converts it to binary, is now actually has this long repeating binary string of numbers, and it needs to stop that at some point. Like computers can only store so many digits, which means it's going to round at some point. Um, and if it only had to round once, that wouldn't be so bad. But if this is some kind of calculation going on a loop, like you have to use it over and over again, right? The more you say multiply by that number, whatever you're going to do with it, the more the errors compound until you get some very serious error.
Great, I get it. And now for real world examples. I read that a rocket crashed because of the way the programmer stored numbers in this binary format. Can you
Mhm.
explain that? Why that
Mhm.
crash happened?
Yeah, so this crash happened in 1996. It was the Ariane rocket, which was I don't know the word, sorry, we'll have to edit this out, but it was the Ariane rocket, and this was part of the European Space Agency's program. Um, so what happened with the rocket was that there was an Ariane 4, and that was all fine. Everything went well with that. Um, but in updating it to make the Ariane 5, the programmers reused a lot of the code. What they didn't realize was that using some of the, with the old code in there, they had a, a long number, a big number, which was stored as what's called a float, which is uh, 64 bits. And bit is binary digit, so it's just like one of those zeros and ones that you see on the screen. So it's 64-bit number. but the program needed to convert it to an integer, which only has 16 bits. And when it did that, it overflowed. It was okay for a little while, but once the number got big enough that it really mattered, that it could only store those 16 digits, then things started melting down. The rocket crashed. The satellites on it were destroyed. It was a financial disaster. So that's a pretty elaborate example of rounding error.
But it's a very good one. Thank you so much, Mimi.